Okay, so diagram shows path curve y equals 2 cos of a third x. So this is, well, it's like my cos x curve, but it's obviously times by 2, so it's a stretch of scale factor 2 in the y direction. So it would be 1, so that's actually 2. And it's a third of x, so instead of it being squashed by a factor of a third, it's actually expanded, and it's enlarged scale factor 3. So that bit is 3 times as big. It would normally have been 2 pi, so therefore this bit is 6 pi, because this means stretched scale factor 3. So I've got to, it's given by alpha, I've got to work out the next smallest positive solution of the equation. That would be here. Pretty obviously, that's going to be alpha back from there, so that will be 6 pi minus alpha. And the smallest positive solution of where equals minus k, well, that means I'll be drawing it like so. So it's going back here. That'll obviously be 3 pi, because it'll be half of that 6 pi. And it's going to be coming back minus k is there. We want this bit here. So again, fairly obviously, it's going to be alpha before the 3 pi. So that'll be 3 pi minus alpha. And then we've got on the paper, I'll just put it in here now. Put some up in. Okay, so it's there. And it's drawn y equals, it's a y equals 2 cos third x. It's printed here. On the diagram of the same value as x, sketch a curve of y equals sine of a third x. Right, so it's a sine of a third x. So sine will definitely start here, rather than starting at 2. And it's a sine of a third x, so it'll still take 6 pi to get right to the end. So when it gets to the end down here, and it'll be crossing over as it goes up to 1, because it's not 2 sine third x, it's just one of them. So it will go through that point there. The next one, when this is at the bottom, this will be there. And when this is there, this will be at the bottom, but it'll be minus 1 now. And then it's going to have the same period, so I'll get back to here. So now all I have to do is just join those points up. I do it with a smooth curve, but that's not too bad. Second part done, and now part 3. I have to calculate the x coordinates of the point of intersection given of these two curves. So basically, I've got sine 1/3 of x equals 2 cos 1/3 x. And I'm pretty obviously I need to get tan x really, don't I? So I'm going to divide both sides by cos 1/3 x, and that will give me tan 1/3 x equals 2. And so 1/3 x equals tan to the minus 1 of 2. So that'll be 1/3 x equals, and it wants it in radians, correct 3 significant figures. So tan to minus 1 of 2 in radians will be 1.107148. And tan repeats every 180 degrees, or in terms of radians, that'd be pi radians. So I need to add pi n. I don't want 1/3 x, I want x. I've got times through by 3, and that'll give me 3.321044, and then plus, have times this by 3 pi n. And it wants to have the points in intersections. So I want the first one and the second one. First one here and the second one there. So I will get x equals 3.32, or 3.32 plus 3 pi, and that will be 12.746, which equals 12.7 to 3 significant figures. So it's 12.7, 3.32, and that's question 9 and the whole paper done.